in the last part, what we have seen in the same lecture 10, what we have seen is a differential wheel drive kinematic simulation with consideration of omega 1 and omega 2. In this particular lecture, part 2, what we are trying to see the omnidirectional wheel drive kinematic simulation, where we will take one such configuration where the you can say 3 wheels are actually like orient with respect to 120° each. So then we can see like omega 1, omega 2, omega 3 comes, and on top of this omnidirectional wheel having a passive roller. So definitely in the last lecture itself I gave a hint that this can move in a lateral direction, that we can see based on this particular kinematic simulation. So I'll actually like see the second example. So which is actually like one of the phenomena which in the current trend people are bringing it, because most of the warehouse now they wanted autonomous vehicle, either it is actually like automated guided or autonomous mobile robot, but these are actually like supposed to maneuver within the shop floor. Within the shop floor they do not want to actually like move as a conventional vehicle, because the floor is actually like smooth and actually like you can see engineered. So even you can actually like allow the lateral motion, but the same you call omnidirectional wheel or magnum wheel cannot be applied in the real environment. Why? The passive roller will not be giving the same performance if it is actually like non-smooth surface. So that is what the idea, that is why the omnidirectional and magnum wheels are popular in the warehouses. So now we will come back here. I just wanted to give little you can say background here. You can see like this is the point where we call C1, and this is the point what you call C2, and this is the point you call C3. In the sense this is the wheel 1, wheel 2, wheel 3. What we are trying to find omega 1, omega 2, omega 3 equation. So now what one can actually see, you have to fix the frame, but what we usually take along the drive direction you are XC1, then based on the right hand rule you will take the YC1, right. So similarly you can see this is the XC2, okay. So this is YC2 and this is what your XC3, and in that case, so this is what YC3. So why I am actually like putting this, so that you can bring a new variable called alpha. So the alpha is actually like angle between your C1 to the bay with respect to x axis. So in this case alpha 1 would be 0, whereas this one is actually like alpha 2 is exists. For simplicity I am taking it's identical, in the sense symmetric about this point. So it is 120°, and this is another one, this is actually like alpha 3, so which is 240°. So in the sense what I got it, alpha 1 is 0°, alpha 2 is actually like 120°, and alpha 3 is actually like 240°. Why this is important? Because what I am trying to do, I am trying to find out what is dx1, what is dy1. Similarly I will go dx3 to dxy3, right. So for finding that I need these angles, that is why I am actually like bringing it. So now if you look at theta b1, what is theta b1? The angle between you call xb to xc1, that is what theta, you can say b1. So now in that case, okay, this is the xb direction and this is what the y, you can say xc1 direction. So what is the angle? So theta b1 is actually like 90°. So in this case you can see, so this is what the case. So you can actually like extend. So I will just erase it this, okay. So now what we have done this. So now you can see this is the xb direction and this is the angle. So which is alpha 2 plus 90. So similarly you can see here, this is what your case, and you take always counterclockwise is positive, in the sense alpha 3 plus 90°. That is what theta b3 and this is theta b1, okay. Because in the lecture what we have covered in lecture probably 8, which was actually like talking about example, I have directly given this theta b1, theta b2, b3. So you may have a confusion, so that is why I was actually like given this. So now based on this what you have, so you have obtained and the passive roller radius, and as well as you can say the passive roller angle, which is phi. So what phi we have said, so what is the slip direction, and slip direction with respect to y axis, that is what phi 1, or you can take so what you call the passive roller axis, which is actually like angle between passive roller axis along with what you call x axis. In this case omnidirectional, all are actually like aligned with x axis, in the sense the passive roller axis aligned with x axis. That is why we have taken phi 1, phi 2, phi 3 as 0. So, if you do this, what you got it finally the equation what you wanted. So, now you can see that if you apply the 120 degree configuration, so you got the zeta in this form. So, now what you can do? So, what we have did in the earlier case, the same way you can incorporate instead of what you have done earlier. So, this rectangular matrix you have substituted, right. So, instead of that you use this particular square matrix and you do the same simulation. So, I hope you can do this. Anyhow, at the end I will try to show something, but right now this is what the understanding. So, you know like what we have done. So, the zeta you have actually like taken as w into omega. So, earlier case you have taken the w based on what you have obtained in the differential wheel, this particular w you have given. So, now you just replace and you play this omega 1, omega 2 and omega 3 variation, and you have actually like two variable a and L. So, now you can actually like play accordingly and then see what would be the required performance and all. Okay. So, with that what one can see like the second example also like done. So, I will move directly to the MATLAB after showing the third example. So, then it would be easy. So, we will just you can say plug and play the W value. So, now going to the third one. So, the third one you can see like this is a Magnum wheel drive, there are 4 wheels. So, there is actually like distance. So, the distance between 2 wheels in the y axis I call 2d, and the distance between 2 wheels along the x axis I call 2l, and the wheel radius is 2a. So, further you know like the roller axis is like this and your you can say xc1 is like this. So, what would be this angle? This angle is actually like phi, and this is actually like counterclockwise. So, that is why phi 1 is positive, and here for simplicity we have always taken as 45 degree Magnum angle, in the sense phi 1 is 45, and you can look at this, the wheel 1 and 3 are actually like similar in configuration, in the sense phi 3 also like 45. Whereas, if you look at this, the wheel you can say axis and the xc1 is actually like you can see it is non counterclockwise, in the sense it is in a clockwise, it is negative. So, that is why you can see phi 2 and phi 4 we have taken as minus 45 degree in the lecture 8. Now, you got it right. So, now what we need? We need the distance. So, you can see like this is actually like symmetric. So, in the sense this is a L and this is actually like minus L. So, this is actually like minus L. So, similarly this distance is actually like plus d as per the you can say coordinate. So, this is actually like minus d, right. So, now you can actually like get, that is what we did in the lecture 8. So, these are the cases. So, now if you substitute what you will get? You will get this particular you can say final model. So, now again you can actually like plug this and actually like you can play. So, now one easily you can notice. So, when you have 2 wheels that to like identical shape, in the sense, so the wheel radius is actually like a1 and a2 are a, what you got it? So, the W matrix is actually like something like a by 2 as a common factor, right. So, I can rewrite that. So, this is the common factor. Now, you assume that a1 equal to a2 equal to a3 equal to a. So, what you have obtained in the Magnum wheel to Omni. So, Omni you can see that the a by 3 is a common out. If you take it out, you can see that the a by 3 will common out, and you can see this is actually like minus square root to 3, and you can see this is actually like in the other way around I can write, that is easy for me to get it. So, what that? This is 1 by square root 3, this is 1 by root 3. So, this is actually like 2 by 3 and this is minus 1 by 3, this is minus 1 by 3 and this is 1 by 3 has come right out. So, that is why we are actually like interested. So, in that sense, so this is actually like straightforward. So, this is 0, this is minus square root 3, this is square root 3 and this is 2 and this is minus 1, this is minus 1 and this one would be 1 by L and this is 1 by L and this is also 1 by L. Why we are taking this kind of thing? That is what I wanted you to explore. So now I will give a small hint. So what the hint? If you have a 2 powered wheel, so definitely the combination will actually like make it. So when you write the force into distance, what that? That is moment, right? So there the distance would be multiply. Now you recall what you written as a linear velocity. The linear velocity you write r omega. R is the radius and omega is the angular velocity. In that sense the linear velocity you can write it in this form. But right now the last row, what it look like? The last row would is actually like omega component. In the sense omega I can write as v by r. So now you have to be very clear. If you talk about moment, that would be force into distance, whereas the angular velocity, that would be linear velocity divided by the distance or the radius. So that's why you can see that, so this is coming as L, or you can take it in the other way around. So d, all are actually like in the denominator rather than the numerator. The same phenomena you can actually like see it even in the end. You can see that whatever the distance, that is coming in the denominator. Okay. So now you got it, why this a by 4 and a by 3 and a by 2 is coming. Similarly, why the last row is coming, the distance is, you can say something like a reciprocal, or the distance is in the denominator. That is what the whole idea. Now let us actually like move to the, you call a MATLAB screen, and we can actually like try to identify this particular case. So for that I am taking the Magnum wheel first, then we will actually like move forward. So I will actually like move to the MATLAB screen. Okay. So I will just change it as a name just for my understanding. I just put this is Omni. So I will put Omni as OM. So now this would be having 3 omega, right. So now you would be writing omega 3. So I will just take it, this is also 0.5. So now this would be having 2 things. So what 2 things? So the distance is actually like between the wheel frame to the vehicle frame. Now I call it as L. Okay. So now this is what we have used. So in the sense I call it here, this L is actually like, I will put it as 2 times L just for simply, okay, here also I have given L, right. So I will put this is length, or I put L. So here that is fine. So the same L, you can take it as, there I will change it, okay. That is actually like easiest. So I will just change it as that is wheel configuration. So now what I am trying to do here is this LW. So that would be probably 0.3. So now what we are trying to do, we are trying to incorporate this W. This W is no longer, you can say 3 cross 2, this would be 3 cross 3. And if you look at it, what we have done, the first wheel would be in the, you can say vertically upward. So in that sense this would come. So I will take it as a common out, a by 3 as common out. So this is 0 and minus square 3, it taking time, okay, square root of 3. So then you have actually so I will just check what the equation we have used. Okay, so 2, then 1, minus 1 and minus 1. So I will just use it that. So 2 comma minus 1 comma minus 1. The last one would be just 1 by L. Here L is I have written as L underscore W. So this is what 1 by LW. So now what we have done, we have actually like incorporated the wheel configuration matrix based on the omnidirectional wheel. So there are 3 omnidirectional wheels which are actually like having 120 degree apart. So where the first wheel is actually like exactly aligned with the y axis, but it is distance away from L. So that is what we have tried, and now you can actually like run it. So I will just give initially like what we did in the earlier case, we have taken all are equal, right. So now if you are looking in that way, if you put omega 1, omega 2, omega 3 all are equal, what one can expect? So it will move forward, right, as per the differential wheel configuration. But if you look at in this configuration, it won't do that way. Why? Because all the wheels are actually like aligned in such a way that it is a circumference way, and you look at the configuration. So you just look at in this configuration. So the first wheel is actually like giving the velocity in y direction, but the second and third is giving, you can say, other way around. In the sense, what you can see, all three are actually like trying to give a tangential velocity in a, you can say, counterclockwise direction. So in that sense, if you run this code, so what you can see, the vehicle is actually like rotating about its own. That's what you can feel it. So I'll actually like try to see. Okay. So I think so the distance I made it. Okay. So this is not 2D. This I am putting as 0.4 because the D we did not define, right. So now you can see like it is much faster because there are 3 wheels and it is actually like making it rotating. So that's why you could not see any path because that is actually like making it in the same point. So I am really sorry for the resolution. I am just tried, but it did not come up. Okay. So now we will actually like see it is keep on going because we have run for 100 seconds. So but now you can actually like see if you want to move forward. So what one can expect by look this configuration. By looking this configuration, what one supposed to see, the first wheel whatever angular velocity I give, that will try to move, you can say, lateral direction. So you take it second and third opposite direction and the same velocity. What one can see, you can see that that is moving forward. So just to understand that, I'll just make it for that. So I am taking that, I am taking it the configuration also like instead of moving it, I am just showing it, otherwise all the time I am showing inclined way, right. So I am just changing. So now this is, so this is actually like opposite direction and this is having a 0. Okay. So now in the sense omega 2 is actually like rotating, in the sense the tangential velocity will be towards x and this is also towards x, whereas the y component would be counteract and then it go away. That's what we can see. So now if you are actually like looking at, you can see, right, it is moving forward. So now you want to actually like move upward, then don't tell that only omega 1 I give and omega 2 and omega 3 I give 0, then it would go like that. No, not like that. So for that what you have to do, so both are actually like supposed to be same, and now you actually like try to see what would be the case. So you take the picture, then you can actually like understand. So this is going like this and this is actually like going like this, but what you want actually like go upward, right. So in the sense you can see this is giving the velocity component, y axis is downward, here also it is giving downward. So then what you need to know, so you actually like put it the other way around. So both are actually like negative. Okay. So then what one can actually like see, if I give something here also, so you can see some action. So you can actually like feel it, I am just giving a random, you can see, right, some rotation is happening. Why? So you have to actually like see the square root, that's why the wheel configuration matrix is required. You see randomly we have tried, it is not working, right. So now you do in a mathematical form. What the mathematical form? I take the W, you can say case. So what you want only V, right. V is actually like written as, so A by 3 into 2 omega 1 minus omega 2 minus omega 3. Now you just substituted only in the other way around, right. So in the sense what you have tried, so these two are actually like equal to this, so that's what you did, right. So in the sense it is actually like giving 4 omega, but what you are looking at here you did not look at it and here also you did not look at it. So in the sense it's supposed to be opposite direction, so that you can actually like make it. So now you actually like try. So I'll just give this and then we can actually try it. So you can actually like see it. So what you are trying to see, you are not getting it again, right. So why it is so? Because you have to have one thing. So for x axis you can actually like make it, For y axis you have to actually like get it in the other way around. You take this equation, so you want to make it u equal to 0. So then this is supposed to be opposite, but when you are actually like putting it here, it is actually like giving, but what happening here? The third equation, for example, I will take it in a PDF also. So what happening these three? So still there is a moment which is exist, right? So that's why we are actually like unable to get this. So if you want to do this, so we can actually like make it further. Okay. Similarly, we can do the Magnum wheel. So in the sense the lecture, you can say 10 part 3 would be addressing the you call kinematic simulation of Magnum wheel and as well as the one of the special case. So with that the part 2 end here where we talk about the omnidirectional you can say mobile robot kinematic simulation. So we will see in part 3 where we would be seeing Magnum wheel and 2 independent rotatable powered wheel configuration. With that saying thank you.